Welcome to another class with Mathemasoft, and this is the continuation of our series discussion on prime number. We have looked at prime numbers in previous videos, the meaning of prime numbers, and also we have considered the application of these prime numbers when it comes to uh, finding the square root of numbers or writing a number as a product of its own prime factors. So we have done all of these in the previous video. So in this video, we want to begin with using the knowledge of our prime numbers and prime factors to find the lowest common multiples of number. So you may also see this being written, as least common multiple. So when you see this, just know that we are still talking about LCM because the word least can be substituted for the word lowest. So let's first look at the literal meaning of lowest common multiple. Let's look at the literal meaning. Let's say we have been given two numbers, 2 and 4, okay? And we are being asked to find the LCM of these two numbers. So in other words, they want us to actually find the lowest common multiple. That is a multiple of 2, a multiple of 4, okay? But the lowest one, okay, that is actually common to the two of them. So in other words, if I'm to write, multiples of 2, let's write multiples of 2. And then we'll see this in a practical way. Multiples of 2, multiples of 2 can be written as 2. That is, we are going to be adding 2. Those are the multiples of 2. So 2, 4, 6, 8. Let's stop on this. It continues like that. Multiples, okay, multiples of 4 now. What are the multiples of 4? We'll start with 4. We continue with what? 8, 12, and so on and so forth. Multiples of 2 means we are going to be increasing the number by 2, starting from 2 and increasing, by 2 like that. Multiples of 4 means that we are going to start with 4 and then we are going to increase it by 4. So this is what we will have. Now, I want us to really understand the literal meaning of the word least or lowest common multiple. Now, let's look at what are the multiples of 2 that we also have, in 4, that is common to them. So when you look at it, the common multiples to 2 and this 4 is that what? We can see 4 here, we can see 4 here. 4 is what? Common. We can also see that what? 8 is also common to them. We can continue like that. There are so many common multiples of 2 and 4 that we can be bringing out. But we can now write that what? Common multiples now. That is common. The word common means that what? That we can find in both of them. Common multiples, okay? The common multiples of 2 and 4 now is what? We can see that what? We have 4, which is common. We also can see that we have 8, which is common. If you continue like that, you also see the rest of them. Like if you continue with the multiples of 2, you will still see that what? After 8 it will be 10 and then 12. 12 will still be common. Okay, so but we don't need all of them. We just want to show that what these are common multiples. Now, what LCM simply now means is that we should now write out only the one that is what? The lowest out of this common multiple. The lowest out of this common multiple. That is what? The smallest. Or we say the least common multiples. Out of the multiples that are common to 2 and 4, which one is the least? Okay, you can see that we have 4, we have 8. It may continue like that. But out of these common multiples that we have, which one do you think that is the smallest? Okay, that is common to them. Obviously, you see that what? 4 is actually what? The smallest. Yeah. Okay, that is common to what? Multiples of 2 and multiples of 4. And therefore, we say that what? 4 is the LCM of 2 and 4 will be equals to what? 4, because 4 is the lowest common multiples to 2 and 4. So this is just the literal meaning. So it's just like writing out the common multiples to 2 and 4 and then choosing the one that is the smallest. That's the meaning of LCM. Okay, let me give you another example. Let's say we want to do that of 3, okay, 9 and 27. We want to find the what? LCM. Okay, let's find the LCM of this. So if you write out the multiples, okay, what are the multiples of 3? Multiples of 3 is 3, then we have 6, we have 9, we have 12, we have 15. It continues like that. What will be the multiples of 9? The multiples of 9, we start with what? 9, and then we have 18, we have 27, okay, and then we have 36, and it continues like that. Okay, next is what? 27. What are the multiples of 27? Okay, the multiples of 27 will be okay, 27, okay, and then we need to actually write more here. So let me see how we can actually create more space, okay, for this, so that we can clearly see the demonstration of this. Let's bring this down, okay, so that we can have more space for that of 3. So we have 3, we have 15, we have 18, okay. I'm continuing with the multiples of 3. We have 21, and it will continue like that, adding 3 like that. You are going to encounter 27. If you continue to add 3, obviously you are going to encounter 54, okay. And that of 9 also, let's shift it down, okay, so that we can actually write more and accommodate more for this also. So if you write that of 9 also, you see that after 36, you are going to have a 40, that's 45, and then 54, okay. So it continues like that. So for 27 is going to, okay, start with what? 27 and then 54. Okay, I'm just showing you. I just want you to see the literal meaning of the word LCM. That's lowest common multiple. Of course, we are going to see how properly we are to to find this word easily, but we are just looking at the meaning. So if I'm going to write out the multiples that are common to 3, okay, these 3 that are common to 9 and they are common to what? 27. So common multiples now. Common multiples to them that is common. In this 3, we can find 27, and we can also find 27 in 9. We can also find 27 in 27. So the first common multiple to them is actually what? 27. That appear in the 3 of them, that is common to them. So which other one do you think that is common? 54 is common. 54 appears here. 54 also appears here. Okay. So the next one is 54. Of course, once you have written the first 2, you don't need to continue like that actually, because it's the smallest you are looking for and it has already come out already. So you can say the LCM, which is the lowest out of these common multiples here. Which one do you think that is the lowest? That is 27. Therefore, LCM of 3 let's write that. LCM of 3, 9 and 27, okay, 3, 9 and 27 equals to what? 27. So 27 happens to be the LCM of 3, 9 and 27. So this is just a common way of proving it to you that this is what LCM means. Now let's look at proper methods, that we can actually use, so that we don't need to actually, be writing out multiples before we actually get, our answer. So let's look at a literal example here. Let's find an example. Okay. Let's take an example. So let's say we have this example, these 2 examples here, that we should find the LCM of this. Now there are 2 approaches I want to teach you to finding the LCM. judging from our knowledge on prime numbers and prime factors. So there are two methods I want us to use. Actually, those methods, it's not like they have a particular name, but I'm just going to give them, a name. So the first one, let me call it tabular method, because it's just like in form of a table. So tabular method. So don't just cram it that this is the method. Okay, is Mathemasoft that is calling it tabular method. So let's call it tabular method. Okay, because we are actually forming a table, tabular method. So let's use tabular method, okay, to first solve the first one. Tabular method is that we are going to write our 12, okay, we are going to write our 24, just the same method that you have been using during our writing numbers as product of prime factors. I hope you still remember that class. So we have 48. So this is what we have. Now, in this tabular method, we begin to, to divide, okay? We begin to divide, okay, using our prime numbers. So, and you start with the first prime number, which is 2. When you cannot use 2 again, you begin with, you move to 3, you move to 5, 7, 11, and so on and so forth like that. So we can use 2 here. So we have 6, we have 12, and then we have 24. We can still use 2. Okay, we have 3, we have 6, we have, now at this stage you have to pay attention. 2 can still go in 6, 2 can go in 12, but 2 cannot go in 3. So you will not bother. 2 cannot go accurately in 3. Okay, you continue to repeat 3. Okay, because 2 cannot go in it, but you are going to focus on the ones that 2 can actually what divide. So that is LCM for you. So we are using 2 again, but because 2 cannot go accurately in 3, so just bring the 3 down. Okay, leave it like that. But 2 can go in 6, that will give us 3. 2 can go in 12, that will give us 6. 2 can still go in 6, though it cannot go in 3, it cannot go in 3 here. Don't bother yourself with that. Still use your 2, but bring down these 3, because 2 cannot go accurately in it. Bring down these 3, but 2 in 6 will give us what? 3. And then the last number here I can see is what? 3. So we have 3 here, 1, 1, 1. And then you see that what? Our LCM now, okay, equals 2. That's the string multiplication of all these numbers here. That's 2 times 2 times 2 times 2 times 3. Okay, 2 times 2, 4, times 2, 8, times 2, 16, 16 times 3, that will give us 48. Therefore, the LCM of 12, 24, and 48 is actually what? 48. So this is the tabular method. Let's use the tabular method again to do number 2. Our number 2, okay, I'm rolling now. Our number 2, the numbers we have is 9, 27, and 81. 9, 27, and 81. Obviously, 9 is an odd number, 27 is an odd number, 81 is an odd number. 2 cannot go. But I've seen 9 already. In as much you see any one of them that 3 can divide, just begin with your 3. 3 in 9 will give me 3. In 27, I'm going to get 9. In 81, that will be 27. Obviously, 3 can still go. 3 here will give me 1. 3 in 9 will give me 3. 3 in 27, I'm going to get 9. Obviously, 3 can still go. 3 in 1, of course, we know that what? 1 is not really divisible by 3. So just bring down that 1. Okay. And then 3 in 3 is 1. 3 in 9, that is 3. 3 again. Okay. 3 in 1, bring out down 1. Bring down the 1. And 3 in 3 will give me 1. So when you reach this stage, just write stop. Okay. In LCM, you have to get to 1, 1, 1 before you stop. So that's what you should note about LCM. Until the division, result to 1, 1, 1 in all the columns that you have here. That's why you say that you can stop. So I can now say my LCM equals 3 times 3 times 3 times 3. That's the multiplication of all these 3 here. So 3 times 3, 9, times 3, 27, times 3, that will be 81. So the LCM of 9, 27, and 81 is actually what? 81. Now, I want us to look at this that I used as examples here. I did it roughly just to explain the literal meaning of LCM, just for you to actually understand what LCM means. It means writing out the common multiples of number and choosing the word lowest one. But let's see it. The first one I did was 2 and 4. You know, we said that the LCM is actually 4. So let's use this three method to actually what show that what is truly 4. So that's LCM, okay, of 2 and 4. You know, we got 4. So this is just the tabular way of actually proving it. So we can use 2, we say 1, then we say 2. We can use 2 again, we say 1, 1, okay, and then we write stop. So the SCM will be the multiplication of these that we have here. And obviously you can see that that will be 2 times 2, which is equals to what? 4. So that's the proof that show you that LCM of 2 and 4 is actually 4. The other one I did, I guess that's on 3, 9, and 27. Okay, and what did we get when we did that of 3, 9, and 27? You can see that our answer is 27. So let's see, is it correct? Let's just use the tabular method to prove that also. So that is uh 3, 9, and 27. Okay, then like that line. So we have 3, 9, and 27. So I can start with 3, 1, 3, 9, then 3 again, 1, 1, 3, then 3 again, 1, 1, 1. Then I will write stop. Okay. So now that I stop, my SCM will be multiplication of this. That will be SCM equals 3, okay, times 3 times 3. And obviously, that will give me 27. That's how we got 27. So you can also try this, okay? Practice with this. Find the LCM of number 1, you can see 10, okay, 20, and 50. Number 2, the LCM of, let me give you a simple number, 42 and 84. So use these two to practice, and let me have your answers in the comment section below. Just use this tabular method. In the next video, we are going to be solving, LCM of numbers using another approach that is actually different from this. So see you in that class. God bless you. Bye.